Good morning, students.
Good morning, sir.
In the last class, we have discussed about the speed equation of DC motor. We started with the back EMF equation. What is the back EMF equation for a DC motor? This is the back EMF equation, and the motor equation is V is equal to E plus IA R, and the torque equation is T is equal to KE 5 into Ia. From these three equations, we can derive omega m is equal to E by KE5. Then replace the value of E from that equation. What we get? V minus IARA by KE into 5. So we can write it also KE5 minus RA KE5 into IA. And if we replace the value of Ia from the torque equation, so what we get? V by KV5 minus RA by KV5 square into T. It is. Hope you will understand. Have you understood this?
Yeah.
Okay. And for
Yes, sir. Last class we have
yes, tell me.
last week. The last class.
Yes, we have done it in last class.
Yes, sir.
And for
Yes, sir.
shunt motor, what we know that the phi is constant. For shunt motor, we know that the phi
Class
is
is constant.
constant. So we consider Ke into phi is another constant and denoted by K. So what we can write for shunt motor? What is the speed equation at that time? What should be the speed equation? Tell me. It should be V by,
So omega m.
yes, the equation of omega in terms of armature current. First tell me in terms of armature current, then we denote it in terms of T. First tell me the equation in terms of Ia. What should be the speed equation for shunt motor and derive from that equation. So omega m should be V by K minus RA by K into IA,
Are
and the speed equation in terms of torque, what should be Tell me, Ritesh, what should be the equation of speed in terms of torque?
K K phi into IA.
No, from that equation, if we put Ke into phi is equal to K, then what is the form of speed in terms of T? This should be V by
V by
K minus
K.
RA by K square into T.
Yes, sir.
And the torque equation, what is the torque equation? T is equal to K into IA, and E can be written as K into omega n. We can also write like that the torque and the EMF for shunt motor, if we consider the phi is constant. So Ke into phi, this should be another constant which is denoted by K, and replacing Ke into phi by K, we get this four equation. And what should be the equation for series? For series motor, what should this equation? For series motor, for series motor, we know that phi is proportional to the, for shunt motor, we consider phi is constant. It is, can you tell me why it is constant? Why it is constant for shunt motor?
Because sir, it is connected in parallel.
It connected in parallel.
Current. Yes, sir.
Let me draw the, let me draw the diagram of a shunt motor. This is a diagram of a shunt motor. This is V, this is IL, this is IA, and this is IF. Though the supply voltage is normally constant, so we can say IF should be constant because the value of IF is equal to V by RF. RF is the resistance of field coil. So if V is constant, so then we can say IF is constant. If IH is constant, then we can say phi is constant because phi proportional to IF, because phi proportional to IF. So if V is constant, then we can say, if V is constant, if V is constant, then we can say phi is constant. Have you understood, Deepak, Jiaul, Ritesh?
Yes, sir.
Okay. Then tell me what about series motor?
Yes.
Then tell me what about series motor? First, let me draw the a diagram of series motor. Suppose this is a series motor. This is V, this is IA, and this is IF. So similarly for series motor, IF should be, sorry, phi should be proportional to the IF. and we can easily see for series motor IA is equal to IF, so we can write it proportional to IA. So I should be a constant into IA. We can write for series motor. Okay, it is. Did you understand this?
Yes, sir.
Okay.
Yes.
So the torque equation. What should be the torque equation for series motor? The general form is KE T is equal to KE phi into IA. This is the general form. And for series motor, the phi is replaced by this equation. So we can write it KE KF IA square. With this we can write like that. So tell me, after that, tell me what is the speed equation for series motor. The normal form is V by K phi minus RA by, sorry, this is KE phi into IA. So after, if we replace the value of phi by KF into IA, so what should be the equation? This should be V by KE KF IA, and this is RA by KE KF. And if we replace the value of IA we, in terms of T, what should we write? This should be V by, first derive the value of IA in terms of T. What should be the value? Means IA should be root over under T by K into K. So put that value of IA here. So we can write V by root over KE KF into T minus RA by KE KF. आया समझ में रितेश, दीपक, जयाउल? रितेश, रितेश,
Yes, sir.
आया समझ में?
Yes, sir.
Okay.
Yes, sir.
Okay. So if we plot these characteristics, suppose Suppose this is omega n. Suppose this is omega n and this is t. That means torque. And tell me the nature. First, tell me the speed versus torque characteristics. What should be the nature? It is. Tell me the nature. What should be the nature of speed versus torque? It is a noise coming from your device.
What's it?
Noise coming from your device. Suppose, let me first we have to plot the omega versus t. We have to plot omega versus t. So, what is the nature of that? What is the nature of speed versus torque for say shunt motor? What is the nature? Deepak, tell me the nature of speed versus torque
Yes,
of
sir.
shunt motor. What is the nature of the curve? कैसा दिखता
सर
है?
टॉर्क बढ़ेगा तो स्पीड कम।
स्पीड कम आएगा मतलब ऐसा होगा ऐसा होगा Deepak, is it like that?
यस सर।
And what is the nature for series motor? What is the nature of
सर
speed versus torque
डायरेक्टली
for
प्रोपोर्शनल।
because omega is inversely proportional to the square root of the torque. So the nature should be like that. Or you can say this should be the nature should be like that. And what is the nature of omega versus Ia? What should be the nature? It is.
Series motor.
Your audio is not clear.
Sir, series motor. For series motor.
Tell me first for Shunt motor, then for series motor. What should be the characteristics of a Shunt motor? What characteristic? The speed and armature current. Tell me the nature of the speed versus armature current characteristics of a Shunt motor. See the equation. See that this is also like the torque versus speed characteristics, or say this is also like the speed versus torque characteristics. That means the nature should be in drooping nature. For shunt motor, and this is for series motor. And what should be the torque versus armature current characteristics? It is, tell me, कैसा दिखेगा?
Sir, directly proportional.
The directly proportional. That means the equation is like y is equal to mx for shunt motor. This means it is like that. It is like that.
Yes, sir.
And for series motor, what is the nature?
I square.
This is proportional to I square. That means square nature. Square nature. That means it like that curve.
Yes, sir.
Okay. Now next we have to do a numerical problem. So what is the numerical problem? Numerical problem is a 200 voltage, 10.5 ampere, 2000 rpm shunt motor has the armature and field resistance of 0.5 and 400 ohm respectively. It drives a load whose torque is constant at rated motor torque and calculate the motor speed if the source voltage drop to 175. A 200 voltage 10.5 ampere 2000 rpm shunt motor has the armature and field resistance of zero point 0.5 and 400 ohm respectively. It drives a load whose torque is constant at rated motor torque. Calculate the motor speed if the source voltage drop to 175. It means what are given, the V1 is equal to 200, and what is the value of IA? What is the value of IA1?
Sir, armature current point 0.5.
zero point 0.5. No, this is armature resistance. The
Oh,
zero
sorry,
point
sir,
0.5
armature resistance.
is armature resistance,
10.
and the field resistance value is 400.
400.
V2 is 175 voltage. What should be the value of speed at that time? So first tell me what is the value of IA in that problem.
10.5.
10.5. Good. So value is 10.5, and what is the value of speed? This is
200,
2000
2000 RPM.
2000 rpm. And there is another condition. It says the torque is constant because it is written here. It drives a load whose torque is constant at rated motor torque. So what is the formula of torque? What is the formula of torque? T is equal to, for shunt motor, what is the formula of torque?
IA. K omega E. KIA.
K I I A. This is the general form. When the supply voltage is constant, then we can write phi is constant. But here, is the supply voltage is constant? It is. Is there supply voltage is constant?
Sir.
Yes or no?
Yes, sir.
Deepak,
Yes, sir.
Jao, is there the supply voltage is constant?
Yes.
So what is the value of V1? What is the value of V1?
200.
200. And what is the value of V2?
100. 200.
The value of V1 is 200.
175.
And what is the value of V2? 175. That means
175.
is the source or is the supply is constant? Is the source voltage is constant? Or you can say the supply voltage is constant or not?
No, sir.
No. That means we cannot write the torque equation as T is equal to constant into Ia. We cannot write like that because the supply voltage is variable here. So we have to write the torque equation as T is equal to Ke phi into Ia. Where the voltage or where the supply voltage is constant, at that time we can write T is equal to K into Ia. And in case of shunt motor, whenever we consider the phi is constant, then you have to say that if the supply voltage is constant, then we can consider the phi is constant. But where the supply voltage is variable, then you cannot consider the phi is constant. So you have to write the torque equation T is equal to Ke phi into Ia. Okay, it is.
Yes, sir.
Okay. So from this equation, and though the torque is constant, so what we can write from that equation? We can write the phi 1 into Ia 1 is equal to phi 2 into Ia 2. We can write that. Deepak, can I write that? Deepak,
Yes, sir.
so tell me the what is the value of Ia2 from that? What is the value of Ia2 from that equation? I1 Ia1 by I2. So what is the value of phi1 and phi2? Is phi proportional to the supply voltage? Can we write like that? It is. हम ऐसे लिख सकते हैं
Yes, sir. For shunt motor.
for shunt motor? Can we write like that?
For shunt motor.
Yes, because the
Yes.
in
Yes, sir.
actually here the motor type is shunt motor. So can so we can write phi proportional to V. We can write.
Yes, sir.
So we can also write phi1 by phi2 is equal to V1 by V2. So tell me what is the value of phi2 or say phi1 by phi2. What is the value of phi1 by phi2? This is 200 by 175. So what is the value of that?
100 by 70.
What is the value of that? 200 by 175.
8/7.
8/7. So put that value here and calculate the value of IA2. This should be 8/7 into what is the value of IA?
10.5.
10.5. So tell me the final value of IA2. Calculate it.
So 24.
24.
Yes, sir.
What is the value of 8/7?
What, sir?
What is the value of 8/7?
8 by
7.
1.142,
Yeah.
sir.
1.1427 into 10.5.
12, sir. 12.
12. No. Tell me what is the actual numerical value? It should be like 11 point something. 84/7. 84/7. 84/7 means.
So direct put kitchen.
Now tell me what is the final value? 8 into 10.5 divided by 7.
So 24. 24.
24. No, no. It's not like
12, sir.
24.
12.
Because uh, what is the value of 8 into 10.5?
Mm, 12. Yes, sir.
If you multiply 8 by 10.5, what is the value? 84. It should be 84, I think.
12. Yes, sir. 80.
84,
Yes, sir.
84 divided by 7.
12, sir. 12. 12.
12. 12 ampere. Then calculate the value of E1, because what we get, I1 we get and we get I2. Now we have to calculate the value of E1, because the final formula should be, we know that E1 by E2 is equal to I1 by phi2 into N1 by N2. You can write like that. It is. Can we write like that?
Sir.
We know for shunt motor the equation is E1 by E2 is equal to phi1 by phi2 into N1 by N2, because this is actually coming from E is equal to a constant into phi into n, and this is also we can replace n by omega. This n also can be replaced by omega. So at that time we can write E is equal to ke phi into omega. But the main equation is E is equal to ke, or say k. You can write k because, say, right here k, because the actual formula is for the back EMF EB is equal to P phi NJ by 60A. If a machine has been designed, then we can consider P, Z and A are constant. So we can write at that time, or after designing a machine, we can write a constant I into N. So from that equation we can write E1 by E2 is equal to phi 1 by phi 2 into N1 by N2. So we know the value of phi 1 and phi 2, and we also know the value of N1. So we have to calculate the value of E1 and E2. So from the motor equation we know that V is equal to EB plus IARA. It is EB is equal to V minus IARA. So tell me the value of E1 and E2 from that equation. It should be V1 minus IA1RA, and the value of E2 should be V2 minus IA2RA. So tell me the value of E1 and E2. Calculate the value of E1 and E2. Then we put the value on that equation, and from that equation we can easily calculate the value of N2. So first calculate E1 and E2. Deepak, Ritesh, first calculate the value of E1 and E2. What is the value of V1? Ritesh, what is the value of V1? Deepak, tell me the value of V1. Deepak,
Yes, sir.
tell me the value of V1. What is the value of V1?
$200.
200. And what is the value of IA? What is the value of IA?
10.5.
10.5. And what is the value of RA? What is the value of
0.5.
How much? 0.5. So tell me
5.
what is the final value?
Sir, 194.75.
194
94.
point something is there.
0.75.
0.75.
Sir.
That means 195 we can also write.
Yes, sir.
The unit is voltage V. 195 voltage. So then calculate the value of E2 and tell me what is the value of E2.
169, sir. 169.
169. 169.
Yes. 169.
And
Yes,
what
sir.
is the value of V2? 175. And what is the value of I A2? Is 12. And this
12.
is zero point
12
5.
into 0.5
So this should be 169. 169 voltage.
volt. Yes. Yes, sir.
169. So put that value on that equation and tell me calculate the value of N2. The value of E1 is 195 and this is 169. The value of phi 1 by phi 2 is 200 by 175 and the value of N1 is 2000 RPM. So calculate the value of N2. So what is the value of N2?
Sir, 1980.95.
1980.95.
1980.95. 80.
1980.95.
Yes, sir. One
Okay, that
1980
means you can write
RPM.
1981 RPM. So the speed of that motor is 1981 rpm when the voltage is dropped to 175 voltage. That means if the source voltage is dropped to 175, then at that time the speed is 1981. Okay, Deepak?
Yes, sir. Speed will decreases.
Speed will decreases. If the source voltage is decreases, then the speed is decreases also. And Deepak, have you understood?
Yes, sir.
Jiaul?
Yes, sir.
Okay. Now we move on to our next topic, the starting of a DC motor. Starting of DC motor. So first we write the motor equation. What is the motor equation? V is equal to EB plus IARA. This is the motor equation. For DC motor, we can write the motor equation as V is equal to EB plus IARA. It is
Yes, sir.
okay.
Yes, sir.
Then from that equation, we can write IA is equal to V minus EB by RA. Okay.
Yes, sir.
Okay. Now tell me, if a motor has the supply voltage is 200 and the value of B back EMF is sorry, suppose the supply voltage is 220, suppose 220 voltage, and the value of back EMF is 200, and the value of RE is zero point 0.5. Consider that and tell me what is the full load armature current. Just tell me what is the full load armature current. It is, am I audible?
Sir, what is RA?
The value of RA is zero point 0.5. The value of RA is zero point 0.5. So tell me what is the full load armature current. Deepak, Yaul, this is 220 minus
40, sir.
200 by 0.5. That means 40 ampere. And what is the value of starting armature current? What is the value of starting armature current?
Sir, your voice is breaking.
Voice is breaking. So the full load current should be 40 ampere. Am I audible now?
Now, yes, sir, you are audible.
Okay. So tell me what is the starting armature current?
What, sir?
What is the starting armature current? We have
Hello.
calculated the full load armature current is 40 ampere. Now tell me what is the starting armature current, or say armature current at the time of starting.
Uh, At the time of starting,
Starting, yes.
it will be high as compared to
And how much?
2 to 3 times.
2 to 3 times. Okay, let's see how much it is. So tell me first, at the time of starting, what is the value of EB?
At the time of starting,
What is the value?
zero, sir, zero,
What is the value of EB at the time of starting?
zero.
Is zero. Why? You are given a right answer, but why? It is. You have given a right answer, but why?
Yes, sir.
You have given a right answer, but why? Why EB is equal to zero at the time of starting?
सर तो बैक ईएमएफ सर मोटर के केस पे हम वहां पे ये जैसे ही सप्लाई देते हैं तो वहां पे फैराडे लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन पे वो वर्क करता है मतलब उसमें करंट कैरिंग कंडक्टर अगर मैग्नेटिक फील्ड के कांटेक्ट में आता है तो उसमें टॉर्क जनरेट होगा
हम्म,
तो
ये
मोटर
सब ये
घूमता है
सब ठीक है, लेकिन वो बैक ईएमएफ क्यों जीरो होता है?
हाँ
Why the back EMF is zero at the time of starting? Deepak, have you any kind of answer? Deepak,
तो रोटर रोटेट करेगा तो ही बैक ईएमएफ जनरेट होगा
good,
अदरवाइज तो होगा नहीं
good Ritesh.
कि वो फिर जनरेटर की तरह
Because at the time of starting,
अनवांटेड वोल्टेज
what is the value of N?
रोटर विल स्टैंड स्टिल कंडीशन
Rotor, it's in static condition. So the value of N should be zero. Though the value of N
यस
is
सर
zero, so at that time EB should be zero, because the expression of EB is equal to constant phi into N. If the value of N is zero, then we can write EB is equal to zero. So now tell me what is the starting armature current. So tell me what is the value of starting armature current.
So without a starter or with a starter?
No, we have not inserted starter yet. That means the situation is like without starter. That means a motor is running without a starter. So what is the starting current at that time?
A starting current more, sir.
How much?
440.
440 ampere. So if we start a DC motor without a starter, or say we if we give the supply directly to a DC motor, then the starting current is 440 ampere instead of 40 ampere. So what will happen? So what will happen with this? If a current is flowing through the armature is 440 instead of 40 ampere, what will happen? Am I audible?
Armature will get damaged.
Either armature will get damaged, or you can say it will,
Yes, sir.
it may be burned. It may be burned. Okay.
It may be burned.
So what we should do to save the armature, or say the save the DC motor? What we should do?
Adding external resistance.
We have to limit the extra current, or you can say we have to limit the initial high current. What are the procedures we have by which we can limit the current to a path?
Sir, adding a resistance.
That means we can add
We can reduce the value of resistance.
we can
Reduce the
add we can add the resistance on that path. So, or by adding the resistance in armature path, we can reduce the starting armature current. Okay.
yes, sir.
So
Yes,
at the
sir.
time of starting, we have to insert the resistance in the path of armature. So we have to add a series of resistance in the path of armature. In the figure, you can see that there are four resistance connected, or you can also add as many as resistance as you require, or as per our requirement we can add the resistance in the path of armature. So at the time of starting, if we add the external resistance in the path of armature, by which we can reduce the starting armature current. And suppose there are four resistance which are connected in series in armature path. At that time of starting, we just close the S0 switch and open all S1, S2, S3. So at the time of starting, after closing the S0, we can see that there is a high current will flow at the time of starting. So consider this value is I max, IA max. Consider that value is IA max. And what will happen after that? After that, though there is flux is present and a armature current will flow through the armature, so a torque is developed, and due to the torque, motor will rotate with a low speed, and after rotation there is a back EMF on armature. So the value of current is decreasing gradually from I max, and when the value becomes I min, at that time what we do, we close that S1 switch. First what we do, or first what we did actually, we first did S1 close, then start the motor, and the armature current will flow from starting point. The starting point of the armature current is considered here IA max, and from that it will continuously decreasing. And suppose at the time of value of armature current is I mean, we close the switch S1. Then at that time what will happen? It is, tell me.
Yes, the resistance.
The resistance will
What? Yes, sir.
the resistance will
Resistance.
will decreases.
Resistance will decrease step
uh,
by step.
Decrease, the resistance will decrease.
First,
Then what will happen at the time if we close
सर
the
S1
switch
को जब क्लोज
S1?
करेंगे तो
If we close the switch S1, what will happen?
हेलो
बोलो, हम अगर S1 स्विच को क्लोज कर देंगे तो क्या होगा?
सर S1
S1 को क्लोज करो.
करंट S0 से होते हुए S2 S3 वो अपर साइड से नहीं जाएगा, नीचे रेजिस्टेंस का थ्रू से जाएगा,
नहीं, फर्स्ट
रेजिस्टेंस का थ्रू से जाएगा, मिलेगा उसको S2 और S3 का रेजिस्टेंस मिलेगा और
हाँ,
SN
वो S1 से बाईपास होके
और
S
S1 के नीचे वाला रेजिस्टेंस
यहाँ से
हाँ
नहीं
S1 से
जाएगा.
बाईपास होके
हाँ,
S2 S3 से पूरा उधर कंटिन्यू
वो
जाएगा,
जो
रेजिस्टेंस
रेजिस्टेंस है
मिलेगा
यहाँ से
सर,
जाएगा,
ओनली
मतलब
S1 वाला रेजिस्टेंस बाईपास हो जाएगा.
पहले से रेजिस्टेंस घट गया.
Sir, your voice is not what? Yes, sir.
तो पहले से रेजिस्टेंस घट गया.
Hello.
Am I audible now?
Yes, sir.
पहले से रेजिस्टेंस घट गया.
Yes, sir. You are audible.
I am saying, what I am saying, the resistance
एक
पहले से
रेजिस्टेंस
घट
घट
गया.
गया जो S1 से बाईपास हुआ.
हाँ, S1 से बाईपास हो गया और रेजिस्टेंस घट गया. अगर रेजिस्टेंस पाथ में से घट गया तो करंट इंक्रीज कर जाएगा. So the value is goes from I mean to I max again. when we just close the S1 switch, then the value of current is goes from I min to I max at that instant, and after that, though the value of current is increased, then the value of torque is also increased, and it will gradually decreases from I max to I min, because
Sir, your voice is not proper coming. Sometimes it's breaking.
am I audible
Hello.
now?
Yes, sir. But sometimes your voice is breaking.
This is due to network problem, I think. So am I audible now?
Yes, sir.
Okay. So after closing the switch S1, the current goes from I min to I max at that instant, and after that, though the value,
Sir, your screen is not showing.
okay, wait. Is it visible now? Is the screen is visible? It is. It is. Is the screen is visible now?
Yes, sir.
Okay. So after closing the switch S1, the current, the value of the armature current will go from I min to I max at that instant, and then it gradually decreases to I min again, and at that point, at the second I min, we have to close the switch S2, so the current will goes to the I max at that instant, and then it also gradually decrease to I min, and so on. It will goes to a operating its operating point. So this is the operating point of that motor, and we close all the switches. हमने क्या किया, एक मोटर को हमने क्या किया, पहले कुछ रेजिस्टेंस के मदद से हमने स्टार्ट किया। जब स्टार्ट किया तब जो करंट जा रहा था वो कंसीडर कर रहे हैं कितना, आई एम एक्स। व्हेन द motor started, at that time the value of the armature current is Ia max. This is the maximum permissible value of armature current, and at that time the a torque will generate on armature. So due to the torque, the motor will gradually increase its speeds from zero. Due to the increased value of, or gradually increased value of speed, the value of back EMF also gradually increased. So the value of armature current gradually decreases from I max to I min. After, say, at the point IA min, we close the switch S1. So the armature current value get increased to IA max instantly, and after that, though the value of armature current is increased again, so the value of speed, or the value of torque should be increased now again. So after that, the speed of armature should be gradually increased again. After that, the value of back EMF is also gradually increased again. So the armature current again gradually decreases to I min, and at that point we close the switch S2. So the current, the armature current gets its Ia max value instantly, and after repeating this process, if we close all the switches, then the point is, or the final point is P. The final point should be P, which is, have you understood?
Yes, sir.
Have you understood or not? Have you understood or not? How the,
अंडरस्टूड सर। इसमें जो कॉन्सेप्ट है वो जो स्टार्टिंग मेथड है, जो हम लोग स्टार्टर लगा के करते थे,
हाँ,
उसमें भी रेजिस्टेंस को वन स्टेप बाय स्टेप रिड्यूस करते थे।
हाँ,
तो स्टार्टर से सेम कंसेप्ट ये है या इसमें कुछ
actually
न्यू है?
you can use manual starter or automatic starter. आप
सर
मैनुअल स्टार्टर
2.3
भी यूज कर सकते
स्टार्टिंग।
हैं, ऑटोमेटिक स्टार्टर भी यूज कर सकते हैं। अगर मैनुअल स्टार्टर यूज करेंगे तो हमें वो आई मिन में हर बार वो स्विच को क्लोज करना है। मतलब पॉइंट को, वो अगर स्टार्टर जो मैनुअल स्टार्टर डीसी मोटर में था, तो क्या है, वो पॉइंट को एक 1 पॉइंट से 2 पॉइंट में ले जाना है वो लीवर को,
हाँ।
फिर 2 से 3 को ले जाना है लीवर को, फिर फाइनल वो जो एसएन यहाँ पर है, मतलब वहाँ पर जो था फाइनल, वहाँ पर लेके जाने के बाद वो मोटर रेटेड स्पीड में रन करेगा। यहाँ पर हम अगर एसएन को क्लोज कर देंगे, जब एसएन को क्लोज करेंगे तब वो मोटर रेटेड स्पीड में घूमेगा। दैट मीन द दैट पॉइंट इज पी पॉइंट। वही पी पॉइंट
ओके।
है हमारा ऑपरेटिंग पॉइंट, वही है। और अगर ये ऑटोमेटिक करेंगे, मान लीजिए आपके पास एक करंट सेंसर है, अगर वो करंट सेंसर से क्या मेजर कर रहे हैं हम, आर्मेचर करंट को मेजर कर रहे हैं। जब वो आई मीन पे आएगा तब एक एक करके स्विच को क्लोज करना है। ठीक है, इट इज, आया समझ में
यस
आपको?
सर।
आया समझ में कि नहीं ऑटोमेटिक वाला?
ऑटोमेटिक वाला समझ में आया, लेकिन जो ग्राफ है राइट साइड में, उसमें सर मिनिमम कर मेन मोटो था तो मैक्स ये स्टार्टिंग में करंट को मिनिमम करना, तो मिनिमम हो रहा है, फिर ग्राफ में सर फिर मैक्सिमम पे जा रहा है।
हाँ, ये समझ में नहीं आ रहा है?
और वहीं पे थोड़ा सा डाउट हो रहा
अच्छा ठीक है, फिर मैं बोल देता हूँ। पहले जब स्टार्ट होगा, मान लीजिए वो आई मैक्स है पॉइंट,
है।
ठीक है?
ओके सर।
पहले जब स्टार्टिंग होगा, वो जो करंट मैक्सिमम हम अलाउ कर सकते हैं, मान लीजिए आर्मेचर से, वो वैल्यू हम कंसीडर करिए कितना, आई ए मैक्स, ठीक है नितेश?
यस सर।
फिर क्या किया, जब वो मोटर जब स्टार्ट होगा, तो एक्चुअली तो टॉर्क तो जनरेट करेगा ना, जब करंट
हाँ।
जा रहा है आर्मेचर से। और ये देखिए फील्ड में भी एक सप्लाई दिया हुआ है, मतलब यहाँ पर फील्ड करंट जा रहा है, आईएफ जा रहा है, यहाँ से भी एक आर्मेचर करंट जा रहा है, तो मतलब एक टॉर्क क्रिएट होगा, टॉर्क क्रिएट होगा ना,
यस सर।
ऐसा होगा। अगर टॉर्क क्रिएट होगा तो क्या होगा, मोटर घूमने लगेगा, थोड़ा सा करके वो स्पीड इंक्रीज करेगा,
स्पीड इंक्रीज करेगा।
फ्रॉम जीरो, जीरो से वो स्पीड को इंक्रीज करने वाला है। अगर इंक्रीज करेगा तो तब बैक ईएमएफ भी आएगा, जितना
हाँ।
स्पीड बढ़ेगा उतना बैक ईएमएफ बढ़ेगा। जब बैक ईएमएफ बढ़ेगा तो क्या होगा, आर्मेचर करंट क्या होगा,
करंट
अगर ये
डिक्रीज
बैक ईएमएफ
डिक्रीज
मान लीजिए बढ़ रहा
डिक्रीज।
है, तो आर्मेचर करंट क्या होगा, घटेगा। तो ये ग्रेजुअली डिक्रीजिंग एंड वैल्यू गोज टू आई ए मीन, ऐसे करके आया, आई मीन में आया।
हाँ।
तो एट दैट पॉइंट व्हाट विल डू, क्लोज द स्विच एस वन। उस पॉइंट में हम क्या कर रहे हैं, एस वन स्विच को क्लोज कर दे रहे हैं। मान लीजिए एक सेंसर है, उससे हम करंट को मेजर कर रहे हैं, जब वैल्यू करंट का आई ए मीन होगा, तब वो सेंसर बोल रहा है कि आई ए मीन आ गया। तो एक देयर एक्चुअली ए कंट्रोलर, बाय दैट कंट्रोलिंग सिस्टम वी क्लोज द स्विच एस वन। तब एक हमारे पास एक कंट्रोलर है, वो जो सेंस, वो जब वो करंट का वैल्यू आई ए मीन आएगा, वो जब सिग्नल देगा कि आई ए मीन आ गया, तो तब हमें वो कंट्रोलर वो क्या करेगा, तो एस वन स्विच को क्लोज कर देगा। जब
यस सर।
एस वन स्विच को क्लोज कर दिया, तब देखो क्या होगा, ये जो रेजिस्टेंस पहले क्या था, इसमें थोड़ा सा एक्सटर्नल रेजिस्टेंस था, अब ये एक्सटर्नल रेजिस्टेंस का वैल्यू घट गया,
जीरो। हाँ
जीरो
वो हट गया।
नहीं घट गया। जब भी रेजिस्टेंस सडनली, ये जो रेजिस्टेंस आपको आप घटा रहा है, ये तो सडनली घटा रहा है ना, ये तो ग्रेजुअली नहीं घटा है, सडनली घटा दिया।
यस सर।
When you close the switch S1, that at that time what will happen? The value of resistance decrease instantly. The value of resistance decreases instantly.
यस सर।
तो देन क्या होगा, जब रेजिस्टेंस का वैल्यू तुरंत घट गया, तो करंट का वैल्यू इंस्टेंटली बढ़ जाएगा। And
इंस्टेंटली हाँ ऑब्वियसली बढ़ेगा।
हाँ, तो देन द वैल्यू गोज टू इंस्टेंटली, और से एट दैट स्पीड द वैल्यू गोज टू आई एम एक्स।
यस सर।
देन आई एम एक्स को चला गया, फिर क्या हुआ, करंट बढ़ गया आर्मेचर में, टॉर्क और भी बढ़ेगा, टॉर्क इंक्रीज कर जाएगा। टॉर्क अगर इंक्रीज कर जाएगा तो
ईएमएफ इंक्रीज करेगा।
बैक ईएमएफ इंक्रीज करेगा, तो मतलब
करंट करंट
करंट का
डिक्रीज
वैल्यू
करेगा, आर्मेचर करंट डिक्रीज करेगा।
फिर वैल्यू डिक्रीज करेगा ग्रेजुअली।
फिर इंस्टेंट हम लोग S3 को क्लोज करेंगे।
एच टू को क्लोज करेंगे,
हाँ S2 को, सॉरी S2 को क्लोज करेंगे।
तो इंस्टेंटली वो करंट फिर बढ़ जाएगा।
ओके सर।
ऐसे करके करके वो पी पॉइंट में आ जाएगा,
पी पॉइंट में हाँ।
आ जाएगा पी पॉइंट में। वही है हमारा ऑपरेटिंग पॉइंट। दैट मीन्स द पी पॉइंट इज द ऑपरेटिंग पॉइंट of that motor, and this is the starting procedure, or you can say starting of a DC motor. This is a, this is the starting procedure of a DC motor, and the resistance inserted in the armature path by the help of A starter, the device by which we insert the resistance in armature path is called starter. और हम यहाँ पर मैनुअल स्टार्टर भी यूज कर सकते हैं और ऑटोमेटिक स्टार्टर भी यूज कर सकते हैं. We can use
Hmm.
here the manual or maybe a automatic starter. We can use manual or automatic type starter. In case of manual starter, we have to change the lever, but in case of automatic starter, the starter will change the value of resistance in armature path depending upon the value of armature current. ऐसा ही होगा.
Yes, sir.
Okay, so this is for today. Have you any question regarding this, Deepak?
No, sir.
Have you understood all these things, Deepak? Have you understood all these things?
Yes, sir.
Okay,
Yes, sir.
okay. So now it is time for the attendance. Ritesh,
Yes, sir.
Deepak,
Yes, sir.
and Jiaul.
Yes, sir.
Okay. जियाउल समझ में आया सब?
Yes, sir.
Okay. So you may leave now.
Thank you, sir.